with both sides are parallel. So that makes QR and PS parallel. And then I'm going to put 2 arrows on the other side to show these 2 are parallel and these 2 are parallel. If that's true, we can say this is a, you know how we put a little triangle symbol in front for triangles? We could do a little parallelogram symbol for a parallelogram. Now, we want to be careful how we name it. We want to go around the shape. We can call this quadrilateral PQRS, but we can't go PSQR, right? That wouldn't make any sense. We want to make sure. But that's not the only way. How else could we name this? You want to, instead of starting with P, start with a different letter. S? Okay.
Why can't you go different?
Okay, so we can go clockwise or we could go counterclockwise, but we can't like crisscross. We could do SRQP. That's fine.
So you can count counterclockwise?
You could go counterclockwise or clockwise. You just can't go like you can't call it SQRP. You know what I mean? That wouldn't make any sense. You want to just make sure you go around. Fred?
You start with Q and then go.
Yeah, you could call it Q.
Clockwise is
PSR. QPSR. That's fine.
Which is counter and which is?
Well, which way does the digital clock doesn't count. Well, how does a clock usually go? This way. So we say this is clockwise.
PQR.
And then this way is counterclockwise. Okay.
Wait.
It's just a different way to name it. Oh. Okay. All right. Now we're going to learn if you have a parallelogram, in addition to the sides being parallel, they're also congruent. Okay, what does that mean? That means QR is equal to which side? PS. And PQ is equal to RS. Now, they're not all 4 necessarily the same. Okay, they could be, but it's just the opposite ones that have to be the same. So here's our first example, FGHJ. So this one is a parallelogram. So notice they named it going counterclockwise. Again, it doesn't matter. Find JH and FJ. So if, let's see, JH has to be the same as FG. So this one has to be 5. And HG has to be the same as this one. So these 2 are 3. No work to do. So it's just literally just matching up. The opposite sides have to be the same. Good? Yeah? All right. Well, what about the next one? AB has to be 9. And AD has to be 8. Easy, right? Easy peasy. Just matching opposite sides. Okay, we have another theorem. If we have a parallelogram, opposite angles are also congruent.
Like Q and S and R.
Yeah, which ones would be opposite angles? So Q goes with S, so it's kind of diagonal to each other. And then P has to be the same as R. So for example, I don't know, let's just go with, let's say this is just an example, 110. So what other angle would also have to be 110? S. Now, if this is a parallelogram, what do we know about like these 2 angles? They have to add up to what? Well, all 4 have to add up to 360, but these 2 have to add up to 180. So this one would have to be.
Is this like a how is it 180?
Oh, because they're parallel lines. So remember, when you have
Right. Yeah.
when you have consecutive interior angle or same side interior, these two have to add up to 180. Now you could double check, like, do all four have to add up to 360? Yes, they do.
Oh, this is so.
Yeah. Oh, this is what I had just mentioned. So here, consecutive angles are, well, consecutive means, sorry, that was supposed to be supplementary.
Do you do the little lines for them or no? No, because they're not.
Well, no, because here, like, here, I'll give you a different measure. Well, let's say this was 105. What would angle P have to be? If they're supplementary.
175 or 75.
180 minus 105, though.
Yeah, 75.
75. And this one would also have to be 75. So these two are consecutive, and these two are
Can you
consecutive.
keep this for
And then this one would also have to be 105.
Can you keep this up for a second?
It just means if you have basically in a parallelogram, if I give you one angle, you can figure out all the rest. So if I gave you, here, I'll give you a different one. Let's say I told you that this was 50 degrees. So I can find the two across, like the consecutive angles. If this is 50, this one would have to be 130. And this one would also have to be 130.
And also because
And then this one would have to be 50.
opposite angles are.
Yeah, because the opposite angles have to be the same, right? So across from each other, they have to be the same, and the ones that are next to each other have to add up to 180. Always, always, always in a parallelogram.
I think these are also the answers
I
to
don't-
the
yeah.
next two.
Oh, sorry.
Yeah.
What, I already gave you the answers?
No, I'm saying that. Yeah, basically. Yeah.
I don't think
Oh.
it's
Oh, for this
supplementary
four, or 3 and 4.
Supplementary is
Okay,
really
so
added.
back when we did parallel lines, we had something called same side interior, where if you have a parallel lines, and I gave you, like, let's say this was 5. How about 55? Okay, if I gave you that was 55, same side interior angles have to add up to 180. So this would have to be. So isn't a parallelogram have parallel lines? These are also same side interior. Just
the difference to know if it's supplementary or congruent?
oh, the last theorem.
Congruence 90 degrees.
The last one was saying the opposite angles were the same. Listen, these two theorems overlap. Okay.
They can both be in the same.
They yeah.
Are they not just exactly the same?
No, because one of them is saying opposite angles are congruent. The other one is saying consecutive angles are supplementary.
Wait,
So,
I have a question.
We're going to use both theorems for example 3. Yeah, go ahead.
Because like in like a quadrilateral, because like a quadrilateral can't always be parallel, right? Like
Right.
So like it only applies depending on what the like polygon is, right? So if the polygon was like some weird like shape, then it could just be supplementary, right?
Okay.
But it's always basically supplementary.
It's always.
Okay.
Yeah. Okay, so if this one's 70, what other angle is 70 degrees? R.
And then you add 180.
Here we can. Are we okay if we just label it? We don't have to.
Yeah.
Okay. So then what do Q and S also have to be the same, but they have to be supplementary to 70. So 110 and 110. Good. So again, if it's a parallelogram, we know all 4 angles. Oh, I do. 105. So angle B also has to be 105.
And then
75. Are you sure we're okay with this? Good. I think this is easier than the last lesson, to be honest.
I really like this.
Yeah, it's not. It's we're going to focus in on like later, like rhombus and rectangle and the other ones. Okay, now one more theorem. The diagonals bisect each other in a parallelogram.
You mean like cut in the middle?
Okay, so that means cut in the middle. So I'm going to draw the diagonals.
So they're like equally
So these two parts are going to be the same, and these two parts are the same. But all four are not necessarily the same. Okay, when the diagonals, so it says the diagonals cut each other in half, but the diagonals, notice like, take this. What happens when you stretch the parallelogram? What happens to this diagonal? It gets bigger and bigger and bigger. This is bigger than this diagonal, right? However, they're always going to cut each other in half.
depending on if it's like
If it's a parallelogram.
yeah.
Yes, if it's just a regular quadrilateral.
What's an example of like a not parallel quadrilateral? Like, can you show one like a polygon that's not
Like a trapezoid. We did them
really?
in the last lesson. Okay, find TX. So if this is 3, what's TX? 3. That's all. Now, do we have enough information to find the other two parts? No. And see? You see how this diagonal is way bigger than this one?
Isn't WT
Like these two parts are congruent here and here. But we don't know. We only know that these two parts are both 3, but we don't have enough information for the other.
UV go with TW though? Because it's like a cross.
UT goes with VW, yeah. Okay. Match the segment or angle in parallelogram JKLM with a congruent one. Okay, so we're just matching what parts are congruent. So JK is congruent to LM. And we know that because opposite sides are congruent. Okay, that's our reasoning. These are what kind. So when we're looking at the reason, we're just describing what's going on in the picture. Okay, angle MLK is congruent to KJM.
Oh, I'm right.
Mm-hmm. And that's because opposite angles are congruent.
If we were bisect,
Yeah, here and here.
Yeah.
Okay, angle JKL. So this angle is congruent to LMJ. Same reason though. Opposite angles are congruent.
Can you show?
Oh, here and here and here and here.
Oh, that's so much easier. Than
You
just
see it
like,
now?
Oh, that's so much easier.
Okay, how about the next one here? I'll label the next one. JN is congruent to. So this segment has to be congruent to what else? Wait, I think I heard it. NL.
Yo,
How do you do?
I'm ready.
Okay,
How
take.
do you do JN?
Wait, where's the? Yeah, may I take the desk right next to you? Yes, thank you.
Yeah, just take it out in the hallway. These two are congruent because these. M
Just pause
and
for a second on this.
Shut up, bro. You're gonna see
David, we're in the middle of the lesson.
Oh, test?
Lesson. Okay, M and L. Oh, this one's a different one. What's M and L congruent to, Fred? K and J. It doesn't matter. And these are vertical angles. That's actually a review from way back. Yeah, those are vertical angles. Okay, last one here.
Will you pause
Oh,
for it? I
sure.
gotta write some stuff down.
Oh, yeah, sorry.
I can open it. It's
Okay. NM. So NM is here. That has to be congruent to KN. And it's the same reason as the one right above it. Diagonals. Shh, David.
Sorry, I'm an evil arrow.
Oh, this one's so easy.
What's the easy? Oh, the next page?
Yeah, we did this before, right?
We didn't do it with parallelograms yet, but
Don't you just go across from it?
yeah, so, okay. So how do I find, we have to find the values of x and y in the parallelogram. So that means 9 has to be the same as x plus 1, right? So what's x equal? 8, good. And then we know 2y plus 3 has to equal, well, 15, but then when we solve, we get 2y equals 12. Divide both sides by 2. It is 6. Last one, and then looks like we have a good amount of time to get the homework. Good?
So the idea of X.
Oh, here, we don't even have to solve for anything. X has to be the same as 2.5, and y is equal to 4.